In this video, I'm going to explain why I'm not using Excel anymore for computing calculation. So the idea is not to say that Excel is wrong, blah blah blah. The idea is more to use this topic to talk about very more important topic, like for example the reproducibility or results, the reusability of what you do, the quality of data, the versioning, things like that. So let's go. So first of all, I would like to postulate that scientific calculation requires a minimum level of rigor in order to reach a minimum level of confidence on the results you produce. That means if you don't have this minimum level of confidence on the results, you can't discuss results, you can't make decisions. So, and for me, in my opinion, Excel is hard to reach this minimum level of rigor by design. By default, Excel doesn't encourage you to reach this minimum level of rigor compared to a computing language dedicated to scientific computing, for example. And with this kind of language, usually by design, you reach this minimum level of rigor without further effort. Just you have to do it like this way. And now I would like to present two main points regarding Excel, which will bring some drawbacks, I think, again regarding the minimum rigor I think is necessary to reach in order to do scientific computing. So first main point, Excel is not dedicated to scientific computing only. It's a very general purpose software. And this is very important to remember that, because if you want to do something in, for example, in MATLAB, and your boss said, why don't you just use Excel? You can say that MATLAB is dedicated to scientific computing and not Excel. So MATLAB is not the alternative, Excel is. And it's very important to remember that. And about MATLAB, just to talk about this few seconds, here I will use MATLAB as comparison with Excel a lot because it's very used in the industry I work with, and a lot of people use MATLAB. So I will talk about MATLAB to compare with Excel, but just want to say that MATLAB is maybe not the best language to do scientific computing, depending on the application of course, but it's a very not liked language by developers. If you see some survey, usually Excel is very on the bottom of the list of appreciate languages. So just to want to point that out before continuing. And about MATLAB, I would like to say that I will compare in this video Excel to MATLAB because it's very famous in the industry I work with, but I want to say that MATLAB is usually not very appreciated by developers. If you look at some surveys of what language developers like, you will see that usually MATLAB is on the bottom of the list. So usually MATLAB is not very appreciated by developers. But again, it's a very famous software, so I will use MATLAB to compare here. And the second point I would like to talk about regarding Excel by design is that this software is what you see is what you get software, or very close to that. I mean, what you see on the screen is what you get at the end, is what the user will see, is what you will deliver sometimes. And it's difficult to make a real separation on what the developer do and what the user can do. You see, compared to a programming language where it's obvious that the developer sees something very different compared to the user. So it's like in Microsoft Word, when what you see on the screen, what you write, is very close to what you get at the end on the PDF or what you print at the end. The document is very close to what you see. And this will bring some, I think, drawbacks, this behavior. So first, I would like to talk about the different version of Excel depending on the country you are, because this could be very annoying. For example, in France, we have a comma as decimal separator and not a point. And the point is mainly the standard in scientific computing. All the tools you use usually use a point as decimal separator. And so when you copy and paste data from another software to Excel, Excel could not recognize this data as numbers, and you can have it could be very difficult to debug this, even if it already happened to you in the past. Usually you don't remember that, just forgot. So here in this video, if I could recommend just one thing, is to put a point as decimal separator in your Excel. It just takes a few minutes to do it, and after it's done, forever. I think it's very important for scientific computing in order to avoid very spurious errors. And also in Excel you have different names for the formula you write on the cells, depending on the country you are, and also the syntax could be different. For example, you can have a semicolon or comma to separate input parameters, and this also could bring very spurious error if you just take formulas from the internet. Usually the resources are in English, and so you copy an English formula in a French Excel, and so it doesn't work, and it could be also very hard to debug sometimes. Here it's not very as important as a decimal separator, so I will not recommend anything, but me personally, I just put everything in English because it's where I found the largest resources on the internet is in English, and so it avoids me some spurious errors. So now let's talk about the quality. So what I mean by quality is what we mean in programming language. Usually there is what we call the trade-off triangle, where we say that it's difficult to have a fast execution of your code, so fast code, and flexible code, which can do a lot of things. The user can choose to do very different things, and a quality of data at the end. That means a high level of confidence on the data. That means be sure that data are not corrupt, things like that. So usually it's difficult to have three of this element: quality, rapidity, and flexibility. Usually you can have two of them. For example, a very fast code with a very high quality on data. You have a high degree of confidence of the data you produce. But your code is not flexible. It's just to one thing and one thing at all. And with Excel, I think this quality is quite low by design. Again, without doing much effort on it, I think the quality is very low compared to a computing language. Why? Because I think there is a lot of source of error in Excel, and it could be very hard to debug. For example, it's very easy in Excel to corrupt a cell. So here I have generated some random data. Here, for example, fictive experimental data coming from, for example, a test bench or anything. So in X and Y, and here I calculate a model. It's a polynomial model with three coefficients here, A, B, C. I calculate the error between the model and the experimental data. I calculate the square error and an objective function here, which is the sum of the square error. So with this we can do some fitting in order to fit the model to experimental data. So I have done some videos about that, about fitting. So I'm not so I'm going very fast here just to have some random data to talk about. And here I just look at the error if it's lower than the threshold, and I just count the number of times it's lower than a threshold, for example. So at the end, I just need, for example, these values of parameters after fitting, and this value where the error is lower than some threshold. But I have to deal with all the data all the time, even if at the end I just need this and this, for example. So this is a problem due to what you see is what you get behavior. I can separate intermediate calculations to what I want to show at the end to the user, which is really different compared to a programming language where you can write thousands and lines of code, but the user see just few things on the screen, or just a file which is generated at the end. here what the user sees is usually what the developer sees. I mean, by default, and without doing further effort, because we could try to for example put intermediate calculations in just one one sheet and limit the access to this sheet. So we can do more advanced things, of course, in order to reach a more rigorous behavior, but by default Excel doesn't encourage you to do that. By default Excel encourages you to just do this and have all the intermediate calculation accessible by the user. And this could bring some very spurious error, because sometimes you just enter wrong values here without knowing it, I mean by accident, because you are doing something else on the second screen on Outlook, I don't know, and you just enter a wrong value here in this cell and you just don't see it, and so you save your file like that, and the next time you open it you see that there is very strange points on some figures and you don't understand what happened. You can spend a lot of time on it. For example, if this value is entered at the line 10,000, I don't know, it could be very hard to find. And also sometimes you are just looking at what the function do, and again you are doing something else at the same time, and you just change something like that, and your formula is correct. But here in this time I got an error, which is good news, but sometimes you just have no error because you just move something without knowing it, again by accident, and the next time you open the file you don't understand why some data are different. So this is what I say when I think that this could be very easy to corrupt. Data could be very easy to corrupt because they are all the time here. There is a lot of data, but you don't use it, you just use this, but they are here, they are accessible. So this could bring to very annoying errors, and it could be very hard to debug because, as I said, sometimes you don't have any errors, you just have wrong formula or wrong value. Also about the formulas, for example here I calculate the Reynolds number with the velocity, the density of the fluid, the viscosity and the hydraulic diameter, for example, and I think this is quite hard to read. B1 times B2 times B4, you have to make a lot of lot of steps to understand what the function do, and here is B4 and below is B3 and on the contrary, so it could be very hard, and if you have a very long formula and links between sheets it could be very complicated. But I think it's hard to read compared to computing language. For example, here I have the same function which calculates the Reynolds number with velocity, but written in MATLAB here, and this function takes the hydraulic diameter, the density, the viscosity and the velocity. Here I have some description of the inputs which can be done on Excel too, but here this is the difference. The calculation is really easy to read. The density times velocity times hydraulic diameter and viscosity is very easy to read, and if you debug this function you can just debug it one time and reuse it 1000 times in a lot of projects, and in MATLAB there is one function per file, so you just reuse the file, and usually you don't have to open it. You usually just never open this file when you have already debugged it. But in Excel is not the case. As I said, sometimes you just, when you want to see what do the function, sometimes you change thing like that, and so you have a problem, you have to debug your formula. It happens, but in a computing language usually if your function is already debugged, it's a very simple function, usually you don't have to debug it again, and in Excel it's not always the case, and it could be very annoying. every time you open the file, you are not sure that nothing changed by accident. And in programming language, it could also happen, but the problem is very less important, because if you write something here, you will get an error, and errors are your friends, because you will find where you put something wrong. Again, here, if I put another letter by accident, I will get an error because this variable doesn't exist. So usually in a programming language, you can do very annoying errors like in Excel, I think. Link between sheets could be hard to follow. I will say that it could function. It could be very hard to debug and read when you have links between sheets. And the copy paste behavior, I a bit talk about that before. But if I return on this this sheet, for example, let's say I copy paste this last line here. I have to be careful that this formula is calculated, and here is not the case. So here, this value here is maybe wrong because I'm not calculated the last case. So this is very annoying with computing language, depending on how it is coded, but usually you don't have to worry about that, because if the size of this vector increase, maybe the size of this one will increase automatically, or you will get an error. And again, errors are your friends, because you will see that, okay, I don't have the same size of the vector, so I have to do something. But Excel doesn't tell you that this value is not correct here. You don't know it, because Excel can't know that this vector should have the same size as this one. So just to say that every time you copy and paste something in Excel, you have to be very careful, and you have to check things, which would be not the case in computing language, in programming language. That means the level of rigor here needs efforts to be done, and compared to programming language where you already get the right rigor, I think, in this case. And also, sometimes you use Excel for dealing with data coming from another tool, another modeling tool, for example, as ANSYS or Maxwell, I don't know, and you copy paste the data. And after you figure out that you have done something wrong in the simulation, so you do again the simulation and you copy paste again the data. And this, when you do that, it's very risky, because sometimes you copy paste the new data, but the new data don't erase all the previous data. So you have remaining data from the previous modeling, and this could bring very spurious behavior. You look at your curves and you see that some points are not consistent, and you could be 10 people in the meeting regarding this figure and try to figure out what is wrong, and it's just because of a wrong copy paste, and this is very annoying. And this happens I think often. And sometimes also you paste not from the first line. It happens also sometimes you do things very rapidly, and this point is not is coming from a previous data or anything. And again, you have these points very strange on the figure and everything. So this happens also. I saw this. I see this regularly when I work with some clients which use Excel. So again, as I said, usually if the data are produced by a computer, data from experimental test bench or modeling software and everything, if the data are produced by a computer, you must import them automatically. You must avoid manual manipulation of this data, because it's more risky if you manipulate manually than if you import automatically. And Excel doesn't encourage you to import automatically. It encourages you to just copy paste, and so to do manual manipulation. So just for that, I think that Excel is not good to reach the sufficient rigor I talk about, because by design it encourages you to copy and paste data. But you can try to do better. You can import data automatically in VBA, for example, in Visual Basic. I will talk about Visual Basic just after. And also about large data set. I think I don't like to work with very large Excel files. I really work with files that you have to zoom out and zoom in to move in the file, because they are very large, and even each time you want to change the formula, it takes time to compute everything. So I think it's really not how to say comfortable to work with large Excel files, even if Excel have made much progress in the past, but I dislike this. So for me, it's a limitation of the software when you reach big files. And as I said, it's very easy to accidentally corrupt a cell when the file is very big. So I think it's a limitation of the software. And about the limitation, I also think that rapidly, when you do some data treatment on Excel, rapidly you need to do some iterations, some iterative process. So you need usually a for loop or a while loop, and here it's very hard in Excel to have satisfying formula. So I think this is also a limitation of the tool, and you need to use a VBA, so a Visual Basic, in order to do such thing. But Visual Basic is really not dedicated to scientific computing. My opinion is quite hard to develop code in a VBA compared to directly a computing language dedicated to scientific computing. And also it's important to know that VBA is also very very disliked language by developers, also on the bottom of the list, like MATLAB. And you also have to develop on the environment given by Excel. So you can develop somewhere else, but usually it's not satisfying. So the development, I think, is quite long, I think, compared to real programming language, let's say. And in my opinion, when I have to deal with VBA, I think I tell to myself, okay, I should not use Excel from the beginning. I should directly go into a programming language, because in the past I developed a lot of VBA content in order to treat experimental data, for example, and always I would regret it, because I reach a limitation of Excel rapidly, again with very large file, or because I want to do some very optimization, things like that. And so usually I regret that. But when you have spent a lot of time on a file, on an Excel file, it's very hard to start from scratch in another computing language. So usually you just keep that. It's not satisfying, but you deal with it. And at the end, I think it's not satisfying. So if this is my feeling, it's just my experience, and so now I just don't use Excel, even for very little things that Excel could be very interesting, because I could get the result very fast. Usually I just not use Excel because I'm afraid of reaching a limitation, and I'm afraid of have to say, oh God, I should have just write it in MATLAB, and I will not have these problems. So this is why I just don't use Excel. It's my way of doing, unless of course if a client asks me to use Excel, or if I have to deliver something in Excel, of course. But if I don't have any demand like that, I just don't use Excel, because I'm afraid of reaching a limitation, even if Excel could be interesting in a lot of cases. And about the time to develop things, Excel in Excel you can develop very rapidly things. It's very satisfying. But when you do everything in Python or MATLAB, at the beginning it's longer to develop because you have to write all the function for plotting and everything, for importing files and everything. But when you have this set of functions and you just reuse them, then I think you could be even more efficient when you have to do something very simple. And you don't have to do things again and again, because each time you restart an Excel file, you have to replot the figures and put the titles and everything. But in a programming language, if you just reuse a function, you don't have to rewrite everything. So you don't start from scratch every time. So I think you could really be more efficient, but of course I'm not sure of that. I have no proof of that, but this is my feeling. So just to say that even if you have the feeling that wasting your time by doing a programming language, I'm not sure in the long run if it's really the case. Okay, so now about the reusability of what you do in Excel. I have just talked about that a bit just right now. But first, I would like to talk about the how to say, the separation between what you see and what the developer see again, because, for example, in a programming language, usually when we write something which needs to be used somewhere, usually we write it on one place and only one place, and we reuse it maybe 1,000 times, but it's written just in one place, and so if you want to change it, you just change it at one place. So this is a very common practice. It permits to maximize the reusability of your code. If you give your code to someone else, it would be easier for him to use it, because if you want to change something, you just have to change it on one place. And it will also facilitate the maintenance of your code. Again, if you change things, you don't have to change things everywhere. For example, here I calculate the stack power, fuel cell stack power, for example, in kilowatts. And here, this is the value of the stack power. So this is what we called a variable in a programming language. So here it's a couple of two cells, of the content of two cells, so the name of the variable and the value of the variable. But in a programming language, the name of the variable should be something like that, for example, stack power, I don't know. So something dedicated only to the developer. Okay, so you don't need to make it very clear. I think maybe the unit is not useful, because it depends on how you write the code, but usually when you write well your code, you can avoid to put the units in the variable name. So for example, the variable name is simpler to use for the developer. And if some values have to be shown to the user, you have to write this kind of very user-friendly names. But just for few parameters you want to display. But in Excel, again, because it's what you see is what you get, usually by design, usually you are forced to have very expressive names everywhere, even if it's just something which is used just one time and the user doesn't modify it. You have to be very explicit on the name in order to the user to understand what you do. But again, you can avoid this. You can try to separate what the developer do and what the user see. You can separate things, intermediate calculation, in different sheets. You can do that, but it's an effort, and again, by design, Excel doesn't encourage you to do that. But the problem is, when you reuse a name here, the stack power here is reused in a second variable, here for a maximum threshold. But let's say you want to change this, I don't know, you change your mind, or your client changes mind, and you don't want to calculate the stack power now, you want to calculate the cell power. Okay, so you will have to change this every time stack power appears in your file. So you can do this by find and replace things, but usually find and replace is not perfectly accurate. Sometimes you change things you don't want to change, and sometimes you don't change everything everywhere. So usually you could have files not not satisfying files where there is still some stack power somewhere, but you know it as developer and you deal with that because you know it's not a stack, it's a cell. But the first time you give your file to someone else, he said, what is that? I don't understand. At the first time you open it. So you could have some, as I said, unsatisfying files rapidly by doing find and replace things. It's a bit like commands on programming language. Usually commands could be very outdated compared to the code, because they are not changed automatically. They are not updated automatically. So here, what I should do in the programming language is just to automate this name compared to this one. So this is what I have done here. If I change cell here, is it modified automatically here with this function? Okay. So it's possible in Excel to write things only at one place and reuse it everywhere you need it. But this function, I think, is very hard to read and hard to maintain, and if you give this file to someone else, or if you don't use this file, let's say for a week or a month, it could be very difficult to you to modify it if you need. So I think it is not really satisfying this, but I do this usually when I have to use Excel because I don't know how to do it differently. So this formula extracts this, the name and the unit in order to put everything good. So if I change the unit, it changes it automatically. But let's say in the future I want to change the unit parentheses by square brackets. Here I have an error, so I have to change here in the formula. So I have to go into the formula and to understand what it does. So here I have to change 3 symbols in order to get the formula working. So here it works. So the good behavior would be to put the square brackets as parameters also. So just don't do this, but do this and this and this. Okay, it's working. And so here, if I change by parentheses again, and here parentheses, okay, so here it works, everything is automated. But this is very strange to find this in an Excel sheet, and how to name this in order the user to understand that okay, it's just used in automating calculation, and just I don't have to worry about it. I think it's not the place for doing that. So you can, as I said, put this on another sheet which is just for intermediate calculation. The user don't have to look at it, and you can also make these cells not accessible for the user. You can do things, but by default it's necessary to put more work on it in order to reach this this automation, which is really easier to do in common computing language. It will be very transparent because this variable will not be shown to the user, it's only to the developer. So, as I said, there is no real separation between internal variables and displayed variables, even if you can try to be closer to this behavior if you want with further work compared to, I think, a computing language. So intermediate calculation, I have already talked about that, and constant variable separation is a bit the same idea. Because, for example, when I calculate the Reynolds number here, for example, maybe the density is a constant, I don't know, and so it could be very interesting to put the constant in another sheet where I put all the constants so I can see what is modified and what is not modified. It's very good practice to do that. But if I do that, I have link between sheets, and it could be hard to follow. It could be harder to reuse this function if there is link between sheets. It could be very hard to reuse function in Excel. Sometimes I just have to write them from scratch again because I didn't succeed in just copy and paste the formula in another Excel sheet. Okay, and now the versioning. So the versioning is a very important point. I can't talk too much about that, but in the industry, usually when people use tools like MATLAB and Excel, usually, and Word, Microsoft Word, usually they don't really know about this kind of tool, about versioning tool like a Git, for example, a very famous tool. But if you look at developers, for example, all of them use a versioning software, and usually Git, because it's very efficient to work with this kind of tool, because it references different versions of your project, of your code. You could have hundreds of files in a project. You can save the state of each file, and it will be referenced, and so you can go back to a previous version. For example, if you have a bug, you go back to a previous version, you take the piece of code you want to restore, and you go back to the current version, you put the piece of code, and now it's working. It's very easy. And also you can go back to a previous version you deliver to a client, even if you are working on a new version at the same time. You can very move between versions. Everything is referenced. You have who modify what and when every time, so it's very easy for collaborating purpose. For example, you modify the code and you send your new code to a validator, and the validator can see each thing you change compared to the previous version. It could validate or not. It's very common tools used in collaborative project. So again, I can't talk much about that, but it's very important point. And when you have tested this, when you are working with it, it's quite impossible to go back and to avoid using it. It's very useful, and I think here we can say that you are very more efficient with this kind of tool. And when a developer see some Microsoft Word document, when you have a table at the beginning of the document where you write manually which paragraph have been modified by which people at which date, this is like I don't know I don't know how to say, but like the middle age when you see that as a developer, because usually it's completely automated things when you use versioning tool. But for using this tool, you have to use text files, because it's very efficient for text file. And so if you use Excel or MATLAB, it's possible, but usually it's not used because you are you use the integrated MATLAB interface, but it's also possible. But usually, because people don't use very text file, they don't know about these versioning tools. But I think again it's a very important point here. And now, what I mean by too much feature, it just it's a bit funny to say that. It's just because Excel is very easy to access. It's very user friendly. You can very rapidly take data from a test bench, take data from another modeling tool. You can put screenshots of another modeling tool. You can put a picture of your test bench and everything. You can put text. So it's easy, for example, to make test report, for example. It's very easy to do. You have the feeling that you are very efficient. But using Excel as reports or experimental test reports, I think it's a bit risky. Again, I think we can't reach the level of confidence I want to reach, because, as I said, Excel doesn't encourage you to import automatically data. You usually just copy paste, and as I said, it's the first point to avoid in order to avoid corrupt cell. And as I said before, all the things I said that cells can be corrupt easily, I think it makes Excel not really suited for being a report. But as I said, you can, with some effort, limit access to some cells and everything, so you can reach something satisfying. But by default, usually people don't do that, and so for me, the good way to do a report is to make it automatically and to generate a PDF. I think it's the best practice because, for example, if your simulation change, you will not have to manually change all the figure or the screenshot, because there is a risk that you forgot to change one, or you do it wrong. And so again, you are in a meeting and you are discussing about a picture that is very strange, but it's just because you don't update the figure. But if your report is generated automatically, the figure could change just automatically when the software generates a new figure, something like that, and the data will change automatically when the software change the results. So you can automate things and be much more confident in what you show at the end, and the PDF is less modifiable. So I think it's a better choice for test reports. So is what I mean by too much feature is just to say that when the software is very easy to access, very user-friendly, you have a feeling that you are very efficient, but at the end, on the long run, maybe you could spend a lot of time because you just forgot to update one picture or a data set. And about databases, so this is not directly linked to scientific computing, but it's the last case where I still used Excel files, is for storing a lot of values every day. So for example, I have an Excel file for where I store the all the hours I spend on the project client, all the cost I have, for example the phone, the taxes and everything. So I have to write lines on these files, sometimes several times per day, and at the end I could know my real sorry, I don't know the word in English. What I gain per hours of work exactly, and how much taxes I pay and things like that. So at the end, I just take few information, but I have a very huge file, and I have to do a lot of copy paste and manually, and to be very careful of if everything is following, and a lot of things written manually. So now already I regret to use Excel for this file. It could be very interesting to use a dedicated tool for databases, like for example MySQL or PostgreSQL, or I don't know, because I could do some automatic query. I could have a query for a revenue, a query for a cost, a query for a tax, and have to write less things manually, and so also avoid corruptions of cells. I think I would be more efficient doing that. It's my feeling. So now I already regret to use Excel even for that. And I also already saw some Excel file for that in some previous company I worked. A very huge file for referencing, very huge Excel files for referencing documents. For example, you have to write some information about your document, and it generates automatically a reference. But as I said, it was very huge file, very hard to use it, and I think for this kind of behavior also I think Excel is maybe not the right tool because it's not dedicated to that. So as I said, I think it could be very hard to play with large file, and at the end I just need few important things. So it's very, it just exactly what databases are good. That means you have a lot of data, but you just need few information from this data. So you just need one or few queries from your data. So to sum up, as I said, my postulate is that scientific calculation requires a minimum level of rigor in order to reach a minimum level of confidence on the data you generate in order to be able to discuss these results and to make decisions. So this is my postulate. And with that, I pointed out that for me there is two main characteristics of Excel that are annoying for this for reaching the minimum level of rigor. First point is that Excel is not dedicated to scientific computing only. It's very important to remember that, and is what you see is what you get software, so it's very hard to separate what the developer see and what the user see. Also, I think there is quite a problem on quality of the results. It's very hard to make the files not corrupt. It's possible, as I said, but it needs more effort than, for example, if you use a computing language, in my opinion. And of course, also you rapidly reach limitation of the software, for example, large files, and if you want to do some iterate process, and you will have to do some Visual Basic. And some people really like Visual Basic, so it's okay. I would not recommend anything, but me, in my opinion, when I have to do Visual Basic, I just think that I should just start with a computing language from the beginning. The reusability, I think, is lower with Excel than a computing language. And the versioning, as I said, I should spend a lot of time on this because it's very important and it's very not famous in the industry, but versioning tools are just amazing. And when you have learned to work with that, it's difficult to work without. And too much feature, as I said, a very quite funny characteristic here, but it's just to say that when you use a very user-friendly tool, you can do a lot of things. You have a feeling to be very efficient. Sometimes it could be you could lose time after on the long run because things are not automated. This video is coming to an end, so I hope you learn things and you appreciate it. Again, I hope I haven't offended anyone here. It was not the goal. The goal was to talk about topics that are important for me. So voilà, bye bye.